Okay, let's begin. On Monday, you've got a homework assignment due and an exam. I'll just revisit the exam parameters one last time here in a minute, but we've talked about it before, so hopefully that's not a surprise for anybody. Just this morning, I've put a resource onto Blackboard that you may find useful if you're looking for some supplemental materials to prepare for the exam. So just to revisit, the course schedule and syllabus has an outline of which topics are going to be included on the exam. So this is posted on Blackboard, and I gave it to you at the beginning of the semester. And you can see all of the different lecture topics that are emphasized for the second exam. And then here on the other part of Blackboard, at the very bottom of our main class page are some extra practice problems. So, and there's no guarantee that these are the questions that will be asked on the exam. These just happen to be some extra practice problems that I had from a previous semester. So there's a practice problem just where you could revisit incremental rate of return and the solution. Another one for external rate of return and the solution, and then a problem for incremental benefit cost analysis. So those are three of the things that are included in the exam, but there's lots of other things as well. So this is by no means an exhaustive list of all the things that you need to study, because there's other things. This is just what I could put together with the time that was available.
Thank you so much.
You're welcome. I hope you enjoy those problems. Yeah. You'll have a great weekend. All right. So the exam's on Monday. Bring your computer. Remember that you have to start with a blank workbook, and there will be enforcement of that. You shouldn't use any previously created spreadsheet file. Now, you can put whatever you want on the page of notes, and that could include a screenshot of Excel, but when it comes to opening up Excel, you need to start with a blank workbook. On the equation sheet, I'll provide any factor tables that I want you to have, and if you don't have a factor table that you think you need, then that means you should use the equation method. So, on certain problems I may say that you have to use the factor method. Certain problems I'll say that you have to use the equation method. But if it doesn't say either way, then you have the flexibility to choose one or the other if the factor table is provided for the interest rate that applies. Okay, so any questions about the exam before we talk about payback analysis? Oh, I haven't finalized it yet, so I don't want to box myself in by promising you a certain number. I don't know how many questions it'll be. My goal is that a quick student would maybe be able to finish the exam in 25 minutes. I think everybody should be able to finish the exam in 40 minutes. Unless you don't know the material, then no amount of time is going to feel like enough. So, you felt like it was too long? Well, maybe you can stop by later and I'll see if this one's okay for you.
Well, I feel like this one's gonna feel longer because stuff with external rate of return kind of just takes a while to set up on Excel. That's the main thing. I feel like that's the issue.
Thank you. All right. So let's say that you're considering equipment like a steamroller, and there's some initial acquisition cost, and you're going to have to borrow money to purchase it, and it's going to generate a certain amount of return. So that's the whole reason that you would acquire new equipment, is it's likely to generate profit even though you have to overcome paying interest expenses for borrowing the money. So that being the case, one of the ways to analyze whether an equipment purchase is justified is trying to understand how long it's going to take to pay off the loan. We've done something very similar to this in the past with a slightly different twist to it. So we're just revisiting the subject today. If you wanted to know how long the loan could be paid off, One thing that you may also ask is, how does that payoff period compare to the useful life of the equipment? Think about if you buy a car and it's going to take you 8 years to pay off the loan, but the car only has a useful life of 3 years. That would be a bad situation. Nobody wants to be paying off loans for things that they don't own and can't use anymore. So this is an initial screening kind of analysis that we can do in payback analysis. And so this is just to revisit the spreadsheet that we've seen before, where what we did, remember, is we assumed that either we were borrowing money to initiate some new business, or it was our money, but it's the sort of thing where we could have invested it into an alternate account that had a certain rate of return. So we just assume that there's some unrecovered balance. And this is the lecture where we were talking about that hot dog food truck, where we were discussing that initially at the beginning of the first year, that the unrecovered balance was just the amount of the loan that you took out, but then during the first year, interest accumulates such that at the end of the first year, not only do you owe the $85,000 that you borrowed, but you also owe the interest that applies to that initial amount. So you can calculate just using the equation method or the factor method, you can figure out how much the payment is going to be during each annual period. If you're going to be paying off equipment, for example, in 5 years, which was the illustration that we did for that previous example, we calculated the payment amount using find A given P. But then what that allowed us to do is to calculate how much of that payment was covering the interest that accumulated, and then therefore how much of that payment was going to retire the principal or to go towards bringing down the unrecovered principal balance. So this is probably a spreadsheet that you still have on your computer, this example where we went through, and in the end we found it should go to pretty close to zero. It's not going to be exactly in a lot of cases just because of an odd number of years. But this is a way of breaking down the declining balance of yet unrecovered funds. So regardless of whether, depending on what your perspective is, whether you're the investor and you're waiting for your money to come back, or whether you're someone who's borrowing money and you're keeping track of the loan balance over time, this technique can be used in either approach. So this is something similar to what we'll do again today. Just to define some terminology, the payback period is how long it takes for the revenue or the cost savings that justify the purchase to cover the initial investment cost plus some given rate of return. So this is a good time to reiterate that when we buy equipment, maybe it's not only because it's going to generate new revenue, but it may be just saving you money. And then that is equivalent to a revenue. So think about what if it is insulation that you're putting into a building. The insulation itself may not make your organization more productive. If you put insulation in the warehouse, that's not going to speed up the assembly line directly, but it maybe would reduce the amount that you spend on heating and cooling costs so that that savings in what was previously spent is considered as a revenue. So there's some justification for an initial outlay, and if you take that into account plus the rate of return that has to be covered, the payback period is how long it takes for the savings or the new revenue to justify it. Now, simple payback would simply be if the interest rate is zero, then how long does it take to cover the initial investment? And that would be the case of where you're just dividing the initial purchase price by the revenue each year, and then that would tell you a certain number of years. But it's not that simple in nearly every case because you can't borrow money for free, and also if you have money, you could have put it somewhere else. And so there's always an opportunity cost associated with the value of the second best option that you could have been investing in. So discounted payback is more typically the kind of analysis that we'll do because we'll want to discount any future revenues at the interest rate that applies. And then with all of that discounted future revenue, we're trying to find out how long will it take to break even or pay back the initial purchase price. So we have to be careful about how we use payback analysis. It's good for initial screening, but we can't necessarily use payback analysis by itself to choose which alternative is best. And the in-class exercise that we'll do today, I've set it up specifically to show you that the item with the lowest payback period isn't necessarily the most profitable item, but it can tell you whether or not as an initial screening tool, it can tell you whether equipment is suitable. And what you'd want to know is compare the useful life to the payback period. So if you're thinking in terms of decision criteria, the decision criteria that you'd apply is if the useful life is greater than the payback period, then it passes the initial screening. But if the useful life is less than the payback period, then the item fails the initial screening, and it wouldn't be a suitable investment. So we can use payback analysis for comparing alternatives given some very specific limitations are in place. And so if the equipment both has the same useful life, let's say you're comparing two options and they both have the same useful life, and if they both have the same productivity and profitability such that they're going to generate the same revenue, then you would pick the alternative that has the quickest payback period. But it's only if both of those things are true, then you should use payback analysis for selecting alternatives. Otherwise, it's just initial screening. And the reason why this warning is just grounded in the fact that after the payback period, it's possible that the revenue or the costs could change. And so payback period analysis is just looking at how quickly the item is paid off, but it neglects the useful life of the equipment. So it may be that one piece of equipment is paid off more quickly, but it's less durable. And so that in the long run, the more expensive equipment, which isn't paid off as quickly, it might generate more profits if it continues onward generating revenue beyond the life of the cheaper alternative, which breaks down, is retired, even though it was paid off more quickly. So that's one aspect of it, is that if they have different useful lives, payback period won't be sensitive to that, and it wouldn't point you towards the alternative that is the most profitable because of the payback period. And then it's also possible that the cheaper equipment, which was paid off more quickly, it may have increasing operating costs in the later portion of its useful life. So if its operating costs are going up, then that could be another aspect that makes it overall less profitable. So we have to be sensitive to those two factors and just use payback analysis for initial screening unless this two-factor criteria is satisfied. Then we could use it for comparison. Okay, let me hand out this in-class exercise. So P is 92,000, A is 11,000, so the P divided by A is 8.364. So let me open up the factor table and we'll look at the crossover point. Okay, so if you find the P divided by A column and you go down, you can see that it's gradually increasing, and we want to know when is that ratio of P divided by A greater than 8.364. So it's after 14 and by 15, it's 8.5595. So what that tells us is by 15 years, the item is paid off. Okay, so we can verify that with Excel a couple of different ways. One is to set up the table with the column titles that are described here. If we set up a table with year, amount, PV of amount, and then unrecovered investment balance. So unrecovered investment balance, as it says here, you're subtracting the present worth of the inflow from the initial cost of the alternative and then just accumulating that over time. So the item costs $92,000 to begin with, and then it generates $11,000 worth of revenue each year. So the question is, what is the value of that revenue in terms of the present? And we use the double comma because when we're selecting some amount, that is being treated as a single lump sum that we're discounting to the present. We want to know what is the value of that single lump sum. And then at time zero, the unrecovered investment balance is just the original amount. But then that's gradually going down in the amount of the present value of the amount. So it is the previous year's unrecovered investment balance plus the present value of that year's revenue. And what we're looking for, remember, is somewhere between 14 and 15 years is where we should go from a negative unrecovered investment balance to a positive unrecovered investment balance, meaning that now the item is paid off and those additional revenues are pure profit. So if I drag this down through some series of years, what we see is it was negative. We still had some unrecovered investment balance at the end of the 14th year, but at the end of the 15th year, it's positive, which means that we've covered the initial purchase price, we've covered the interest rates, the effective interest since this was borrowed money presumably, that's been taken care of, and now any additional revenue is just pure profit. So if I was going to annotate this, I'd say the item has a positive unrecovered investment balance after 15 years. It is paid off after 15 years. Okay. The handout suggests that there's one additional way to do this, which is with the NPER function. NPER. So see if you can use that. Try the NPER function. Of course, it'll give you little suggested hints as you start typing it in, but it allows you to calculate the number of periods. And so you're going to need to put in both the present cost and the annual revenue. You're going to tell it a number of years. You're going to tell it an interest rate. So it will return how many years are required of that revenue in order to cover the initial purchase price using the NPER formula. So here, NPER, okay, it says rate. It wants to know the interest rate, so that's 8%. And then it wants to know the payment amount. So the payment amount, the recurring $11,000 each year is the payment amount. The present value is an outflow of $92,000. And we can close parentheses, and what it'll do is it'll calculate how many years to bring equilibrium between the inflows and the outflows at that interest rate and for the amounts that are listed. So it says 14.36. So, I mean, that kind of makes sense based on what we see here. If we were going to do like a linear interpolation between 14 and 15 years, in the 14th year, we're pretty close to zero. You know, it's negative 1,300. In the 15th year, we're above zero, 2,100. But it's going to be closer to year 14 than it is to year 15. You can kind of see that in the data. And then that's what's confirmed here when you calculate the payoff period. Now, because of the end of period assumption, we assume that all of that year's revenue comes in a single lump sum amount. So truly, to pay off the item requires 15 years, not 14.4 years, because there's no such thing as 4/10 of a year in this setup. You get the revenue all at once at the end of the year. So 15 years is the payoff period for part one. Any final questions about this one before we move on to part two? Okay, the only thing I want to say about part two before you work on it independently is that machine X, you can see, has a useful life of 7 years. Machine Y has a useful life of 14. So what we would need to do is repeat machine X 2 times to have it cover the same study period. And so when you set up a table, you're going to calculate the unrecovered investment balance for both machines over time. So setting up a table similar to this, but setting up one table for machine X, one table for machine Y, and then we'll just compare how long does it take for the unrecovered investment balance to go from negative to positive for both alternatives.
Did you extend it all the way out to 14 years and get A value and based upon the A value?
So in part 2, we're comparing these two different pieces of equipment. One of them, let's just look at the table of data that we've got. Machine X costs more, generates more revenue in the initial years compared to machine Y, but it only has a service life of 7 years, whereas machine Y costs less, has this early period where for whatever reason it's not generating very much revenue, but then it picks up in the later years and goes a full 14. For us to compare these two alternatives, let's have a standardized study period of 14 years. So that means repeating machine X through 2 cycles. And so that's what I've set up here is I've said we start off by buying the item at time 0 for $12,000. It gets its revenue of $3,000 per year. And then in year 7, we buy the item and get $3,000 in revenue. So the net outflow is only $9,000 when we purchase it a second time. Now, as a consequence, if we were only going to have it for a single series, you'll notice that it gets paid off in the 6th year. But it's a little bit murky if you have to do 2 cycles of it. It's not paid off the second time until the 10th year. So that just kind of illustrates the uncertainty of how to handle an analysis like this when you have 2 different useful lives. And so the way that we should use payback analysis, remember, is as an initial screening tool. So the question we should ask is, are they both suitable? Like, do they pass the initial acceptability test? And both of them do, because machine X, with its initial service life of 7 years for one sequence, for one cycle, it's paid off in 6. So it passes initial screening, and machine Y passes the initial screening because it's paid off after 8 years and has a useful life of 14. So what we could draw as a conclusion for the first part of this in-class exercise is that both of them are acceptable. Now, which one is best really is a question for net present value. Or we could answer the same question by just, what is the unrecovered investment balance at the end of the 14 years? So $8,747 is larger than $5,731. And so we can prove that to ourselves with NPV. Do you remember how to use NPV? We'd apply it on the amounts, not on the present value of the amounts. So we'd apply it only to years that are not already at the present. So if we do equals NPV, parentheses, then the interest rate that applies here is 8%. So I can either type that in or click on a cell location that has the 8% defined. And then we put just the future amounts into the NPV function. And then outside of the NPV function is where we'd add any amount that's already at the present, which is here the initial purchase price. So this is just going to give us the same answer as the unrecovered investment balance at the end of the 14th year. So it says 5731, which is the same as the unrecovered investment balance at the end of the sequence. So machine X has that amount of profitability. This is how much excess profit there is in terms of present value after covering the 8% interest. So remember, when you're purchasing equipment to generate new revenue, but you had to borrow the money to purchase the equipment, some of the profits that the equipment generates go to you, and some of the profits go to whoever you borrow the money from. So what this NPV answers is what is the present value of your share of the profits after covering the borrowing costs. So this represents your share of the present value of the profits. In other words, after covering the initial purchase price and the interest payments. So we could do the same thing with option machine Y. We could do the NPV function on machine Y. So let's do that down here below the statement. NPV. So the interest rate 0.08. The amounts are only those amounts that aren't already at the future. And then outside of the NPV function is where you add the amount that's at time 0. So which item should be picked is machine Y. We should select machine Y since it is the more profitable alternative. Both are acceptable. You're not going to lose money on either of them. Both of them have a payback period that's shorter than the useful life, so that's good. That's why they are both acceptable. They would have a negative NPV if its useful life was less than the payback period. You'd have a negative net present value. For example, if the machine stopped working after 5 years, but its payback period is 6, then you'll have a negative NPV. So based on present worth, on the bottom of the handout, it's asking you to describe which one should be purchased. We should choose machine Y. Machine Y is the more profitable alternative. So any questions about this in-class exercise before we finish for today? Okay, so remember that your exam is on Monday. Please go to the bathroom, get a drink of water before the exam starts because you won't be able to leave the exam room until you're finished with the test. So be prepared, and I will see you later.